Okay, let's look at homework 15, problem number 5. All right. So we want to find the area of the part of the cone z squared equals 3 times quantity x squared plus y squared, which is inside the sphere x squared plus y squared plus z squared equals 16. All right. So let's draw a picture. Let's draw a picture of the image on the YZ plane. Right, so let's draw axes. Right, so here is the y-axis, kind of like that. Right, and draw z-axis. Right, kind of like that. Right, then I just label these. So here is the z-axis. And here is the y-axis, right? All right, so YZ plane, x equals 0. So let's examine the equations. So x equals 0 gives you that the cone, intersection with the cone would be z squared is equal to 3y squared. Then we can just take the square root of both sides. We get z is equal to plus or minus square root of 3y. Right? So it's going to look kind of like this. I'm going to just draw, so it's going to look like, so it's a straight line and slope is square root of 3. So I'm just going to draw a line like that. Maybe like that. Well, let's see about that. All right, then try to draw kind of symmetric here. All right, so this is the negative square root of 3y. Right, so this is what they look like. All right, so this is y equals square root of 3. Actually, I should say z equals square root of 3y. And this guy is z equals negative square root of 3y. Right, then let's say then the sphere, so it's going to be a circle with radius 4. So I'll just try to draw that. So it's going to look something like this. All right, so so let's just say I'm going to make it as big as I can. All right, so something like that. All right, so that's a sphere. All right, so it's got to be inside the sphere and on the surface of the cone. So maybe I should draw let's see the cone in 3 dimensions. So it's gonna look kind of like this, right? And also let's see, that's not what I a little bit higher. All right, so this is the cone, the surface of the cone we want to find. So I'm gonna just shade it a little bit. So this is what we want. Oh, that's not what I want. Right, so here. Right, so this is a cone right there. And those on the back side too, of course. Right, and of course we have cone, actually the exactly the identical piece on the bottom too. Right, so we just find area of the one piece, and then we try to find the just multiply by 2. All right, so this is going to be, all right, first we have to find the secant of gamma. Right, so again I'm going to rewrite this equation as so here is f of x comma y comma z is going to be, right, so I'm going to put these terms on the left. So you have z squared minus 3 times quantity x squared plus y squared is equal to 0, right? Then let's find the gradient. Gradient of f is going to be, right? So partial with respect to y would be negative 6. Sorry, with respect to x, negative 6x. Partial with respect to y would be negative 6y. And a partial with respect to z would be 2z. Right? So if you want to find the gamma, secant of gamma, then you will get magnitude of the gradient of f divided by absolute value of partial of f with respect to z. Right? Okay, so the gradient of f is actually the magnitude. Right, so this is going to be a square root of, right, so it's going to be this guy squared, so it's going to be 36 x squared plus 36 y squared plus 4 z squared. Right, then the magnitude of partial with respect to z would be that guy, so it's going to be 2z. Right, you can put the absolute value sign. Right, right, but you can see that if you we can substitute. So this guy right here is equal to, right? So same thing as this is, I'm going to pull out to 12. That way, this is same thing as 3x squared plus 3y squared, right? But remember that the 3x squared plus 3y squared is the same as z squared. So this is actually 12z squared, right? So this is going to be equal to, right? So this is a square root of 12z squared plus 4z squared. So it's a square root of 16z squared, which is the same thing as 4 absolute value of z. And here on the bottom you have 2 absolute value of z, right? So you can cancel z and z, right? And 4 and 2, so it's going to be 2. Right, so secant of gamma is actually 2. Right, so once you know that, we can set things up. And also here, if you look at this, this right here, right, since the slope is square root of 3, so it's this is 1, and here's 1 square root of 3, and but the radius is here is actually 4. So it's this is actually 60 degrees because slope is square root of 3. So this is going to be 2 right here. So that's 2 right there, right? So we can integrate over this guy right here with radius 2, right? So this is the our D, disk D right here, right? This is our disk D, right? So we want to integrate. So surface area A is going to be, right, I'm going to do one piece and multiply by 2, so it's a 2 times, right, double integral over this disk with radius 2, right? And secant of gamma came out to be 2, so that's 2, right? All right, so this, make sure that, so this is secant of gamma, right? Then you do dx, dy, right? So you can see that this is just a 2 times 2, so 4, right? integral over d with the area element. So this is times area of the disk D, and you can find that. All right, I'll let you finish it. All right, that's it. I hope that this will get you going.